Good morning, class. So in this recording for Unit 5, Lesson 6 notes, we are talking about identifying roots. So again, we're going to be using this square and cube root reference chart a lot because we are going to be utilizing these various perfect squares and perfect cubes. These are the two that we want to focus most of our attention on. So the square root and cube root. So these are the perfect square roots, perfect cube roots. And what that means is that when we take the square root of these numbers, the answer is a whole number, right? So if we take the square root of 16, it's 4. If we take the cube root of 64, it's 4. So that's what this is saying. So square root of 25 is 5. So what we're doing when we're identifying roots is we're basically just simplifying. So we've done this in lesson 4. We've done this in lesson 5. It's the same thing that we're doing here. So we're basically just trying to find the largest perfect square or perfect cube that we can pull out of the number. And so remember, if there is no number, if there is no index here, like a 2 or a 3 or anything like that, then we automatically assume it's a square root. And it's not really an assumption, it is a square root if there is no index. Okay, so what we need to do here for finding the square root of 72 is we need to take a look at this list of numbers, these perfect squares, and find the largest perfect square that is a factor of 72. So right away, I can tell that 36 is a factor of 72. And I know 49 is not, 64 is not, and obviously nothing larger than 72 is going to be a factor. There are other numbers, like I'm sure 4 might be a factor, but we want to go with the largest. Okay, so in this case, the largest is the square root of 36. And the square root of 36 times the square root of 2. So 2 times 36 is 72, so that's when I say it's a factor. That's because if we multiply them, 36 times 2, we get 72. So now what I can do is I can change the square root of 36 down to 6 times the square root of 2. And that is the simplification of 6 times the square root of 2. Or sorry, of square root of 72. All right, so just to prove that those are exactly the same, I know I keep doing this, but I'm just going to keep showing you just to show you that they're the same thing. So we're going to do the square root of 72. So square root of 72, I'm going to move this out of the way. All right, so square root of 72 is 8.485 and so on. And then I'm going to show you that 6 times the square root of 2 is also the same number. So notice that these are exactly the same number. So all I'm really doing is I'm simplifying the square root. So that's what we're doing in these. Okay, so now we're going to simplify a cube root. So we need to find the largest cube, perfect cube, that is a factor of 96. So I know, obviously, we can kind of ignore this line because we're not going to factor 1 out of any of these. Let's see, I think 8 is a factor because 8 times, I believe, 12 is 96. Okay, so we could pull out a cube root of 8 out of there. I don't think 27 is. Is 96 divided by 27? I'm pretty sure is not a whole number, but let's just try it. No, it's not. I didn't think it was. Wouldn't make sense that it would be. Okay, and then 64 is too big because 64 times 2 is already too big. So 8, the cube root of 8 is the largest perfect cube we can pull out of there. So cube root of 8 times 12, because 8 times 12 is 96. So cube root of 8 times the cube root of 12 is the same as the cube root of 96. The cube root of 8 is 2. So if we just look up here, cube root of 8 is 2 right here. So that is equal to 2 times the cube root of 12. And I know it might not seem like it's being simplified because we've actually kind of made it maybe even a little bit more complicated, right? But when we're simplifying cube roots or square roots, we're trying to pull out the largest whole number out of there that we possibly can. That's what we're doing. All right, next one is the cube root of 108. So again, we're just trying to find the largest number that's a factor of 108. I believe 27 might actually be a factor. Let's try it. 108 divided by 27. I think it's 4. Yep, it is. All right. So this cube root, 27 times 4 is equal to 108. So we're going to do the cube root. We're going to break this down to the cube root of 27 times the cube root of, what did we say, 27 times 4. Okay, so the cube root of 27 is 3, because 3 times 3 times 3 is 27. And then times the cube root of 4. So we simplify the cube root of 108 to the cube root, or 3 times the cube root of 4. All right, find the square root of 250. Again, we're just simplifying. When we say find the square root, we're simplifying it. So if we look up here, we're trying to find the largest factor of 250. That's a perfect square. So remember, we're only looking at squares now. We're not looking at the cubes because this is a square root. So I know for sure 25 is a factor. 36 is not, 49 is not, 64 is not. Okay, so it's got to be 25. So we're going to break this down to 25 times what equals 250. So that'd be 25 times 10. Okay, and then the square root of 25 is 5, so this would be 5 times the square root of 10. And now we're going to do the square root of 128. I feel like we've already done that. Did we do? Nope, I guess not. All right, square root of 128. Maybe we did that in a different lesson. So again, we're trying to find the largest square, perfect square that is a factor of 128. And right away, I can tell 64 times 2 is 128. So I can break this down to the square root of 64 times the square root of 2. Okay, 64 times 2 is 128. And then the square root of 64, if we look at our chart, is 8. So we're going to change the square root of 64 to 8 times the square root of 2. And that is it for Unit 5, Lesson 6. So a lot of what we did, so Lesson 4, we did this exact same thing when we were trying to, so if we go back here, hey, look, there's an answer for the quick check. I got to get this out of the way. All right, so in Lesson 4, when we were evaluating roots, we were doing the same thing. The products of irrational square roots really is the same exact thing. So all three of these lessons were basically the exact same thing. So identifying roots, evaluating roots, and products of irrational square roots. These two are mostly just square roots, whereas this one we're actually including cubes as well. So anyways, that is it for Lesson 6. If you guys have any questions, feel free to reach out. Otherwise, have a fantastic rest of your day.